So yeah, one more just an example which I would like to mention over here, which is for the SPI based ADC. Okay, and that is I have given for the same example. Yeah, which is, let's consider the 12-bit ADC as an for the MCP3204. So there will be in datasheet, they will be more specifying the everything, how exactly what are the different timings parameter which we need to consider, and how exactly the what are the data, what are the values we need to put into the input line and output lines, how we will get the data. So if we talk about the, ultimately it will be the if we talk about the SPI, then we have two lines, master in slave output and master out slave in. So those are the same pins which we will have here also, but which we will name is in different way. So ultimately, if to get the ADC values on a D data output lines, we need to send the data on data input lines. Here we will be, depending on data sheet, we will be sending certain bits. Okay. And so here in this example, D0, D1, and D2 are referring to the channel number. So ultimately, definitely, yeah, whenever we have a more than one channel, I need to select the channel, which channel I am targeting to convert and get the values of digital values on the output lines. Apart from that, there could be depending on the which type of ADC we are using, there could be certain extra parameters which we are going to configure and need to send on these lines. And once those are being sent, after certain time, we will be getting the output line. So here in, as I mentioned, this is the 12-bit ADC. So here it has a value from B0 to B11. That's why, because it's a 12 bit, so B0 to B11 are the data lines. Okay, and once we will this, we need to get this value in our any of the variable, and which we will be proceeding to display or whatever action we are going to do. So now this is for the ADC conversion mechanism, and there will be also chip select lines, and most of this SPI based ADC will be letting the data either on a rising edge or the falling edge. And here, if you can see the it is the MCU converts on a rising. So depending on the which kind of ADC, which kind of chip we are using, it will say that data is clocked out. So depending on that, it will let the data either on rising edge or the falling edge. Yeah, moreover to that, we also will have a like ADC selection mechanism. So generally, which type of ADC we need to select, that depends on the what kind of resolution we need, and how fast, what kind of how like depend, because there will be a conversion mechanism by which we will be able to make it very fast also. So depending on that, either we will use the different kind of ADC will use internally different kind of mechanism, and these are the different kind of mechanism, whether it could be successive approximation, data sigma, dual scope, pipeline, and flash. Okay, and each has own pros and cons, its own limitations. Okay, so depending on our requirement, it has the maximum resolution limit as well. Depending on our requirement, we will choose any one kind of these of the ADC for our use. We talk about the input, output, and an ADC processing part as well. Now let's consider the LCD. Okay, so we will be talking about the alphanumeric LCD in this case. So generally, alphanumeric LCD will have the 16 cross 2 alphanumeric LCD we will have, or other option will be the 20 cross 4 LCD as well. Okay, so in the LCD, we will be having the data lines, as you can see, that DB0 to DB7. So these are the different data lines which will be available. We will be also having the three most important signal, which is RS, read, write, and enable. Okay, so these are the most important pins when we always talk about the LCD. Pins will decide how exactly we need to, like what kind of, whether we need to write to the LCD, what data we need to write, what command we need to write, that will be decide on based on these three pins. So internally, LCD will have a two kind of register. One is the command register and one is the data register. Okay, so as we talk about, so LCD will accept the either command or a data. So if we need to send a command or some instruction, we need to use this command register. So required to send different commands, instruction, operations, which we will specify that please operate in this way, please do this way. So there are specific commands we need to send to the LCD. that we need to load into this command register. And now let's talk about the data register. So as its name suggests, it is a data register. So whatever the values, what are the things we need, what are the we need to, whatever we want to print on the LCD, those needs to be sent to the data register. Okay, so data required to send to display. Okay, so if I want to display A, B, C, D, or embedded, whatever things I want to send, I want to display, I will send this to this data register. Okay, so now what are the different kind of commands we have in LCD? There's that also I will show you. Okay, so just for an example, I have mentioned over here, it could be a clear display, shift display right, shift display left. Okay, focus cursor. Okay, so generally we need to, like, let's say I wanted to print the values on the line 1. Okay, so I need to select that line now. Okay, so for that also we have a different commands. I need to select, that's a line 2. For that also I have a separate command. So basically each of this line and the digit will specify the specific command or address. Okay, so I will show you in the next slide what are the different things there. So there is also option provided by the LCD for the shift entire display right or shift entire display left. So we always used to see the scrolling things on the LCD. So LCD also provide that inbuilt support where you can directly display the things, and you can give the command to scroll right or scroll left depending on your need. So there is a specific command for that as well. As I mentioned over here, there will be a specific address which will be defined for the each location. Okay, so line 1, which will be starting with value 80, 81, 82, 83, and it will go till 87. Line 2, which will start from C0 to C1 till C7, C1, C2, C7. Okay, so this is the address range for the LCD line 1 and line 2. Similarly way, we will be having the address range for the 20 cross 4 LCD as well. Now let's see how we can basically select the, how we can send the data to be print on the LCD. What are the different sequence of operations which we need to follow to make that happen? Okay, so we will be having the dedicated, we will have the lines, let's say data bus contain data lines, that is db7 or db0 to db7 generally. So here it could be d7 to d0 to d7 as well. So those are the data lines on which we will be sending our data. One more thing, most of the LCD will provide the 4-bit mode as well to operate. So in that case, we need to send the nibble data in the nibble wise, first nibble first and second nibble. Yeah, higher nibble and lower nibble. So LCD also provide that feature. However, we will not going to consider that for it at the moment on that. But LCD definitely provide that feature where you can have control over 4-bit individually. Now let's consider the register select. So we have a pin as we have seen in this diagram. It is RS. Okay. So what exactly mean by RS is register select. Okay. We have two register as also we have seen in the previous slide, that data register and command register. Data register is being, so we can just see that to display the data on LCD, we should write the data to, like, let's say to select this data register or command register, how we can. So if we make this RS pin as an high, which will select the data register, and if I will make the RS line as an low, then it will select that as an command register. Now after configuring this RS pin to high, and whatever the value I am going to load on this data bus db0 to db7, that will be interpreted as an data, because I am saying instructing the LCD that now whatever the things are going to come, that should be interpreted as data. Okay, not as an command. Now whenever I am going to load the RS value, as in 0 before sending data on DB0 to DB7 line, I am saying, I'm instructing controller that please interpret the DB7 to DB0 to DB7 line as a command. So that's why this RS line is most important line, which will instruct the controller, or which will instruct that I'm going to send the data or a command. So based on that, I can distinguish this. The next important next important pin which comes in the LCD is read oblique write bar, and read oblique write bar will specify that if read if it is value 0, which will indicate the write mode, because it is write bar, and let's consider the value 1, which will say that it is a okay. So depending on that, I will be saying that it is read or write mode. Now enable. So whenever the if I want to load the whenever I want to pass on the data, okay, so I need to send a high to low pulse on enable lines, which will instruct the compiler, which will instruct the controller that please let the data. So if high to low pulse is required to be sent on enable lines, which will latch the info into the LCD register, that will trigger the LCD to act accordingly. Okay, so that is the required things at the end. Let's consider this case where we have different pins. As I mentioned, PDZ, there is a one more provision which will say that busy flag, which is we are going to read in case of if it is busy, LCD is busy. That's why read operation also we have. And the commands, actually we have different commands. As I mentioned, these are the different list, which will be again generic in most cases. We have different commands: clear LCD, clear display screen, return home, decrement cursor, increment cursor, and many more things. Okay, shift display also, as I mentioned. And if you see this 80 and 60, 80 and C0 is the force cursor to beginning, and force cursor to beginning line 2. Okay, so these are to set the cursor position at that line, that this command we will use. We have also option for the cursor blinking as well. We can also make the cursor off. So these are the different commands which we will use for the LCD. And how exactly we will send the data, that we will be specifying over here. So to send the data on LCD, we will make the RS line 1, then read oblique write bar as in 0, because we are specifying that is in write operation. We will make the enable pin high and again low. So this is high to low transition we are making, so data will be latched. So this is the flow which we are going to do for the data send. Okay, and here for the command, the only it is same, the change here is RS line is equal to low, because instead of this RS line 1 will specify the data register is being selected, and RS line 0 will specify the that it is command register is being selected. Okay, so this way we will send the command and then data, then it will be displayed on the screen. So if we need to write the small piece of code where we will send the command, so ultimately this is then one function which will take as an argument, which is an CMD. Here we will just take the LCD data bus, which will get the data from that. Here we will this is the RS line, this is LCD RS line, which will make it 0. Read oblique write bar is also 0, and enable we will give a certain delay, and we will make it from make a high to low pulse. Okay, so this way we will send a basic command, and just opposite to that, where everything is same, we will have RS line is equal to 1 in the function. So this function will write the data, this function will write the command. So same thing is described over here as well, send the command. So we can do the same sequence, we need to follow this sequence for the command, we need to follow this sequence for the data. Okay, so yeah, next point is the 7 segment display. So we have a 7 segment display which we will see at many places. So we need to basically, it will contain the different LEDs which is placed in this kind of fashion, to which will look like 8. So here A, B, C, D, E, F, and G, and we have a last is the dot pointer. Okay, so here it has a two kind of configuration. Most segment LCD will come with the two kind of segment. One is the common anode and one is the common cathode. So in case of common anode, where to make the LED on, we need to give the ground, means low value to that LED, because here we have anode, like all the positive is being common and connected to VCC. So depending on which LED I wanted to make on, I will provide the ground or zero level to that LED, which will make that on. Thus, that is just the reverse case in case of common cathode, where all the cathode will be all connected to the ground, means zero level. And to make the LED on, I need to specify the I need to give the high voltage or value 1 to that LED, or to that specific LED. Yes, then it will make that LED on. So let's consider then this will be the interface diagram for the 7 segment display, where we have let's say common cathode configuration, and here I have a port pins which is being configured. So I will be connecting, and here I will be sending one pulse, like one high value to that particular pin to make the LED on. And here it will be like this, common is connected to the ground. Okay, so let's consider how exactly I will be able to print the value, let's say digit 1 2 3 4 5 6 7 A, B, C, D, E, F, any value, anything. Okay, so in this case, I will have the, considering the dot value also I have, and one is the common. Okay, I will having the control over this the individual LED, A, B, C, D, E, F, and G is being off. Okay, so to make the, let's say zero, I need to turn on all the LED. Only G is required to be off. So A, B, C, D, E, F, I need to make it on. Okay, and dot pointer is also required to be. So in this case, you can see the on A, B, C, D, E, F is being mentioned as an on, and the G which is being off, and the dot pointer is also being off. So this is the corresponding values in case of common anode and common cathode, which, so 7E is being mentioned as in common cathode. Okay, which I need to load to to make the LED and to display the digit 0. Okay, similar way, I will be able to what if I want to make the digit 1, then I need to send this code 2 3. Similar way, we have derived the different codes value which I need to load to display the digit 1 2 3 4 5 6 7 and 8. Okay, let's consider one more case. There I have a multiple, because definitely we need to connect a multiple 7 segment display whenever we are using. So in that case, I need to first do the individual selection of the segment, and then I need to load the value. Okay, so here I will be having the two dedicated pins which will be used for the selection. So using that way, I will select and load the value, select and load the value. I think we have very less time now. I will just go through quickly for these slides, and we will stop. So let's consider a case where we have a memory interface. So in the memory interface, generally it will be I2C based memory, EEprom memory we are talking about. And here also we will be having the data lines clock, clock and data SCL and SDA. So and this is the chip configuration where we will be having the two lines SD and SCL lines, and this A0, A1 and A2 is being used for the selection. Basically it will be address range to select that particular memory. And as we know, I think the start and stop condition for the I2C, definitely it will be the high to low when clock is being high, and if we data line goes from high to low, that will be considered start, and reverse to that, if it is going from low to high, it will be considered as a stop condition. So same interface we will use for the memory interface, and there we need to first basically select the address. Okay, so for the address selection, there will be depending on a chip, there will be hard coded values over 1010 which will be there, and A0, A1, A2 will specify the there could be a jumper setting for that, and using that we will be specifying, we will be selecting the our chip. And depending on that read oblique write operation, so we can also perform the either read operation or write operation to particular memory area that will be specified in this bit. And as it is I2C, we will be having the acknowledgement as well. So let's consider the case where we need to write the values. Then you will send the start bit, then device address, which as I mentioned, that will be the device address we need to give this way. then you will specify whether it is going to perform write oblique read, and in this case it is write. Then you will send the first address byte, so first address, and second address byte, and then you will have acknowledgement as well, and followed by then you will send the data. So this is for write byte. Similar way you will have for the read as well, though it is almost similar. Rather than that, you will have, instead of read oblique write bar, where you will specify the read operation, because that is a value, yeah, so one. So there you will also having the acknowledgement also. So here you will specify the address, and then followed by the data. Similarly, you can have the sequential read as well, where you will read the number of more than one byte and continue to read that value, and at the end you will send the stop signal. This is the same operation you need to follow in this. So this is the sequence of operation which you need to follow in case of EEprom write mode or read mode. Only the difference here is that you need to send the start condition in case of read, because first you will send the start command, again you will send the address and other things, and again you will send the start in case of read. Okay, but where it is not required in case of write. Similar way, you can just after doing this, you can just create your own code to send those address and read or perform the write operation. At last, I think we will just have a look at this slide and then we will close. So generally, we always use the in case of RS232 and RS485, where also we will be having the difference. So where there will be a general highlight to the difference between both of this. There is a voltage level difference, where we will you having the different voltage level from 3 to 25 on logic 0 minus 3 to 25 for the logic 1. The main purpose of using RS485 is whenever if you want to connect more number of device, at the time we will use RS485, and if there is a distance limitation is more also in case of RS485. So both of these the main advantage of RS485, because RS485 is differential based. It is, so there will be, it will be always differential based, and that is the reason where you will have a voltage level range from 200 millivolt to minus 200 millivolt, and you will have a lines A and B. Okay, so both of things, like in RS485 also half duplex is also possible and full duplex is also possible there, where you have a 2 and 4 wire configuration, and you have a data A, B, and ground which is being used. And here in this case, you will use the RX, TX, and ground. Okay, this is RX232 is point-to-point communication, whereas RS485 is multi-point communication, where you will be able to connect more number of device. You can connect up to 32 device, and it can go up to more also. And here in this case, you can able to connect only one device. Distance limitation, as I mentioned, here it will be a maximum 15 meters. Here it will be a at birth rate of 9600. Here it will be 1200 meters at the birth rate of 9600, but that is again a maximum value. It will not be practically possible. It may go less. Okay, so depending on that, we will be able to choose whether we will go with RS485 or RS232. Yeah, depending on our need. And as the you will have the, as I mentioned, RX, TX, and ground, which will be directly connecting to the device 2. And here it is a point-to-point communication, and here it will be a multi-drop. And there we will be able to connect multiple device 1, 2, 3, 4, 5, and many more. So that is the advantage of RS485, and where we will be connecting multiple device. So I think that's all at the moment for this session.